There is a rule in the universe, a law as old and as reliable as gravity itself. It's a simple rule of light. The farther you are from a fire, the colder you feel. The farther you are from a candle, the dimmer its flame becomes. Light fades with distance. It scatters. It weakens. It surrenders to the vast, empty darkness. This law, the inverse square law, governs every star, every galaxy, every flickering light bulb in your home. It is predictable, it is constant, it is true. Except, it seems, for the light from 3I divided by Atlas. On the night of August 7th, 2025, a team of astronomers at the European Southern Observatory pointed the Hubble Space Telescope at a faint, unassuming speck of light moving against the fixed backdrop of the stars. This was not their first look at the object, but it was the one that would change everything. The data that streamed back to Earth was clean, the observation was perfect, and the numbers were impossible. As Atlas journeyed closer to our sun, closer to us, its light was not getting brighter in the way it was supposed to. It was wrong. It was too bright. It was behaving less like a cold, dead rock reflecting the distant sun, and more like a campfire whose flames were growing larger the farther away you walked. It was breaking the most fundamental rule of light, and in the quiet, sterile control rooms filled with the low hum of computers, a terrifying and exhilarating question began to form, whispered at first, then spoken in frantic video calls across continents. What if the light we're seeing isn't a reflection at all? What if that tiny, speeding dot is making its own light? This is the story of that dot, a visitor that arrived unannounced from the void between the stars. It is traveling at over 200,000 kilometers per hour, a speed so immense that it could never be captured by our sun's gravity. It is not from here. It is not one of us. It is merely passing through, but its passage and the strange light it carries with it has ignited the greatest scientific investigation in human history. This is the story of 3I/Atlas. The story truly begins a little earlier. On July 1st, 2025, on a remote mountaintop in Chile, under one of the clearest skies on Earth, a robotic system named Atlas, the Asteroid Terrestrial Impact Last Alert System, did its job. Its software, designed to find moving objects, flagged a new point of light. This happens all the time. It's usually just another asteroid from our own solar system. But when the astronomers calculated its trajectory, a jolt of excitement ran through the community. The path was not a gentle, looping ellipse like a planet or an asteroid. It was a hyperbola, a sharp, aggressive slash cutting through our solar system from interstellar space. It was only the third such visitor we had ever confirmed. The first was in 2017. We called it Oumuamua, the Hawaiian word for scout. It was a bizarre, cigar-shaped object that tumbled end over end, and it accelerated away from the sun for reasons we still cannot fully explain. We saw it only as it was leaving, a fleeting glimpse of something utterly alien. The second, Borisov, came in 2019. It was easier to understand. It looked and acted like a comet, trailing gas and dust, a dirty snowball from another star system. It was strange, but it was familiar. And then came Atlas. At first, everyone assumed it would be another Borisov. Its path was bringing it far closer to the inner planets than the others, offering an unprecedented chance to study it. The world's great telescopes all turned their gaze to the newcomer. That's when the weirdness began. Comets glow, but they do so in a specific way. As the sun's heat warms their icy surface, gas and dust erupt, forming a fuzzy cloud, a coma that reflects sunlight brilliantly. But Atlas wasn't fuzzy. In the world's most powerful telescopes, it was still just a point, a sharp, clear pinpoint of light, a star that was moving. And it was this sharp, stellar point of light that was breaking the laws of physics. The debate raged for weeks. Was there dust around it so fine that even Hubble couldn't see it? Was it made of some exotic ice that behaved in a way we'd never seen before? Every natural explanation was proposed, and every natural explanation seemed to fall short. It was Avi Loeb, the same Harvard astrophysicist who had controversially suggested Oumuamua was an alien artifact, who put forward the simplest yet most profound explanation. He published a short, explosive paper online. The title was On the Self-Luminous Nature of 3 I Divided by Atlas. He proposed that we stop trying to explain how it was reflecting so much light and instead consider the possibility that it was generating its own. The implications were staggering. If it was making its own light, like a tiny star or a light bulb, then it didn't need to be huge to be seen. The initial estimates, based on it being a dark, reflective rock, had placed its diameter at around 20 kilometers, a veritable mountain tumbling through space. But if it was self-luminous, it could be dramatically smaller. It might not be a mountain at all. It could be only a few hundred meters across, the size of a skyscraper or an aircraft carrier. And suddenly, the nature of the object shifted from a geological anomaly to a technological possibility. Because mountains do not glow, but machines do. We live in a moment of shared history, a time when the entire planet is looking up, waiting, and wondering about this single point of light. That sense of connection, of a shared experience across time and space, is a powerful thing. And just as we are all connected by this celestial event, I feel connected to you, the listener, sharing this story right now. Perhaps you could help strengthen that connection. A simple press of the like or subscribe button makes this small community feel a little larger, a little more together in our curiosity. And I would genuinely love to know where and when you're joining this story from. If you feel inclined, leave a comment with your city and the time on your clock as you hear these words. It would be a beautiful thing to see a map of us, all listening together, scattered across the globe but united in this moment. To know that as we return now to the deep darkness of space, to the ongoing story of Atlas, we aren't entirely alone in our wonder. The question, of course, became, if it is glowing, why? What could power a light in the frozen emptiness between stars? The scientific community, now fully mobilized, split into camps. One camp explored the exotic natural possibilities. Perhaps the object was not a rock, but the incredibly dense, still glowing core of a planet that was destroyed billions of years ago. Or maybe it was composed of elements so radioactive that their decay was causing the entire structure to shine with an internal heat, a nuclear furnace adrift in the cosmos. These were wild, fascinating ideas, pushing the boundaries of what we thought was possible in nature. But another camp, quieter at first, but growing more confident, explored the other possibility, the artificial one. They argued that the glow wasn't a byproduct. It was a function. They spoke of the faint heat signature of a fusion engine, converting matter to energy on a journey lasting millennia. They spoke of the waste heat from a generation ship, a world unto itself, housing beings in a state of hibernation. They even spoke of the simplest, most human-like possibility, that the lights were on simply because someone or something was home. And so, as we stand here today, on September 15th, 2025, this is where we are. The object is currently moving between the orbits of Jupiter and Mars, Every night, it grows infinitesimally brighter in our sky. We are watching a visitor approach, and we are faced with two equally reality-shattering possibilities. Either we are about to witness a form of natural celestial object so strange and new that it will rewrite our understanding of the universe, or we are about to witness the single most significant event in the history of our species. The world's telescopes are watching, the world's scientists are calculating, and the rest of us, we are waiting. We are no longer just looking for anomalous radio signals from distant stars. For the first time, we are staring at a physical object entering our home. And for the first time, we have to truly confront the possibility that someone or something is coming to visit. The story is just beginning. To understand the sheer impossibility of 3i divided by Atlas, you have to understand how we found it. You have to go back to that first night, on July 1st, 2025, and look at the raw data. The process itself is a quiet miracle of modern technology. On a mountain in Chile, the Atlas telescope isn't a single giant eye, but a collection of smaller telescopes, linked together. Every 2 nights, they photograph the entire visible sky. They take a picture, wait a few minutes, and take another one of the same patch. Then the software goes to work. It subtracts the first image from the second, digitally erasing the billions of stars, galaxies, and nebulae that have not moved. What's left over are the wanderers, the movers, the things in our own cosmic neighborhood. Usually, this process reveals a handful of known asteroids on their predictable paths. But on that night, the software flagged a series of 4 faint dots of light that weren't in any catalogue. 4 dots that appeared where there was only blackness before. A human astronomer then verified the finding. They measured the position of the dots, calculated the speed, the direction, and the numbers that came back were the first sign that this was something special. The object was moving too fast, way too fast. It was a guest, not a resident. Within hours, this preliminary data was sent to the Minor Planet Center, or MPC, in Massachusetts. This is the world's official clearinghouse for all things moving in the solar system. They are the gatekeepers. They verified the calculations and saw the same thing the Chilean team did, a hyperbolic orbit. This wasn't a looping path. It was a one-way ticket. They gave it its official name. The I stands for interstellar. The 3 signifies that it is the 3rd such object ever confirmed, and Atlas honors the observatory that found it. 3i divided by Atlas was now real. An alert flashed across computer screens in observatories around the globe, and the great hunt began. What I've just described is the standard process. It's how science works. Methodical, careful, and collaborative. But what happened next was anything but standard. As more observatories tracked Atlas, feeding their data to the MPC, the orbit was refined from a rough sketch into a high-fidelity blueprint, and the blueprint was utterly bizarre. It wasn't just that it came from another star. It was the precise path it was taking through our solar system that started to set off alarm bells. Imagine the solar system is a vast, flat, spinning record. The sun is in the center, and the planets are all moving in circular grooves on the record's surface. This flat surface is called the ecliptic plane. Almost everything in our solar system, planets, asteroids, comets, moves along this plane, traveling in the same counterclockwise direction. It's a busy but orderly cosmic highway system. The first strange thing about Atlas's path was its inclination. It wasn't traveling along the flat plane of the record. It was coming in from above, plunging down towards it. That in itself is not unheard of for comets. But its angle was strangely shallow, only about 5 degrees relative to the plane. This is statistically unlikely. Most long-period comets and interstellar objects are expected to arrive at completely random angles, like a bee buzzing into a room. They might come from the ceiling, the floor, the side. For Atlas to arrive at an angle so close to the planetary highway was the first coincidence. It was like someone throwing a dart from across a stadium and having it land almost perfectly flat on the bullseye, instead of sticking into it. The second, and far stranger, detail was its direction. It was moving retrograde. While all the planets are spinning counterclockwise on this cosmic record, Atlas is moving clockwise. It is, quite literally, going against the traffic. This makes it an even rarer object, but it's the combination of these two factors that strains credulity. To be both retrograde and have such a low inclination is a coincidence of vanishingly small probability. It was like that dart thrown across the stadium, not only landing flat on the bullseye, but also having been thrown by someone running in the opposite direction of the stadium's rotation. It's possible, of course. In an infinite universe, anything is possible. But it was enough to make astronomers raise an eyebrow. Then came the part of the orbit that took this from a statistical curiosity to a subject of intense, almost unbelievable speculation. The trajectory wasn't just a simple plunge through the system. It was, for all intents and purposes, a grand tour. The refined orbital mechanics, now calculated with pinpoint accuracy, showed that Atlas was projected to make a series of remarkably close planetary encounters. In early 2026, it will pass within 1.5 million kilometers of the planet Mars. This is exceptionally close in astronomical terms. It's close enough for our Mars Reconnaissance Orbiter, a satellite that has been circling the red planet for years, to potentially capture a high-resolution image. But the choreography doesn't stop there. After its pass of Mars, its trajectory will carry it onward, where it will make another close approach, this time to the king of planets, Jupiter. The combined probability of a random interstellar object entering our solar system and having a trajectory that includes such close passes with two separate planets was calculated. The number, published by a team from the Jet Propulsion Laboratory, was 0.005%. This is a number so small it's difficult to comprehend. It is a level of coincidence that demands an explanation. In science, when you see a pattern this unlikely, you have to question whether it's a pattern at all, or if it's a blueprint, whether it's chance, or if it's choice. And the final piece of this impossible puzzle, the detail that ties the mystery of its orbit to the mystery of its light, is what happens at its perihelion, its closest approach to our Sunday. The trajectory is so precise that at the moment it is nearest to the Sun, and therefore at its most active and most revealing, it will be positioned almost perfectly behind the Sun from our perspective on Earth. It will be lost in the glare. For several crucial weeks, our ground-based telescopes will be completely blind to it. Is this just another breathtaking coincidence in a long line of them? Or is it a deliberately planned maneuver, a path designed to allow close observation of multiple worlds while cleverly using our own star as a shield to hide it from our most powerful instruments at its most critical moment? This is why 3I divided by Atlas is not just another Oumuamua. Oumuamua was a mystery because it was so strange, and we saw it so late. Atlas is a mystery because it is so deliberate. Its path is not a random tumble. It has the elegance of choreography. Its characteristics are not chaotic. They are precise. When you take this impossible orbit, the low inclination, the retrograde motion, the grand tour of the planets, the sun-shielding maneuver, and you combine it with the fact that the object is generating its own light, the argument for a natural origin begins to feel strained. One anomaly can be dismissed as a fluke. Two can be a coincidence. But a string of them, each one compounding the last, starts to look like a message. The object is following a path, a set of coordinates in space-time, laid out with what appears to be impossible precision. It will be at a specific place at a specific time, and we will be there to watch it. It makes you think about your own coordinates in the universe at this very moment. As this story reaches you, as you hear my voice, where are you? What city? What part of the world are you in? And as you glance at a clock or a screen, what time is it for you? It's a fascinating thought, isn't it? That we are all listening to a story about a single, extraordinary point in space, each from our own unique points on the surface of this planet, all connected for a moment by nothing more than a signal and a story. With the trajectory of 3I divided by Atlas established as an event of near impossible improbability, the scientific community fractured. The initial excitement of the discovery gave way to a tense and profound disagreement, a fundamental split in how to interpret the evidence. Two tribes formed, with battle lines drawn not in anger, but in the rigorous language of physics and data. On one side were the naturalists, who argued that while Atlas was undoubtedly strange, it was a product of the universe's vast and often surprising creativity. On the other side were the artifactors, a smaller but vocal group, who contended that the object's characteristics, when taken together, pointed to the unmistakable conclusion that it was a piece of technology. This is the story of that debate, a forensic examination of a visitor that was either the strangest comet we had ever seen or the first true probe from another star. The first front in this intellectual war was fought over the most basic question: what is it made of? The first major piece of evidence came from the spectrographs. A spectrograph is a remarkable instrument. It captures the faint light from an object and, like a prism, splits it into its constituent colors, a rainbow. But within this rainbow are tiny, dark lines, gaps, where specific colors are missing. These lines are absorption bands, and they are a chemical fingerprint. Every element, every molecule, absorbs light at its own unique frequencies. By reading these lines, we can tell what an object is made of from hundreds of millions of kilometers away. When the first spectra from Atlas came back from the Keck Observatory in Hawaii, the naturalist camp felt a wave of vindication. The fingerprints were all there, clear as day, a strong signature for water ice, along with the distinct lines of silicates and carbonaceous minerals. In other words, rock and ice, mixed with carbon-based compounds. These are the exact building blocks of a comet. The data seemed irrefutable. Case closed, many thought. Atlas was a comet. An odd one, to be sure, with its strange orbit and brightness, but a comet nonetheless. They argued that its journey from another star system could account for its peculiarities, that it was formed under conditions we don't yet understand, making it a precious scientific artifact, but a natural one. But the artifactor camp was not so easily dissuaded. For every piece of evidence, a counter-explanation emerged. They posed a compelling question. If you were to send a cold, inert probe on a journey between the stars for millions of years, what would happen to it? The space between stars is not a perfect vacuum. It's filled with a tenuous mist of single atoms, molecules, and microscopic dust grains. Over an immense timescale, this interstellar dust would bombard the surface of the probe. In the cryogenic cold of deep space, water molecules would stick to it instantly, flash freezing into a layer of frost. They called it the cryogenic shield hypothesis. The argument was that Atlas was not made of ice and rock. It had simply acquired a coating of it. Like a car left out in a freezing fog develops a thick layer of frost on its windshield. The probe itself, the machine, could be hidden beneath this accumulated interstellar grime. This theory cleverly explained the cometary signature without dismissing the artificial hypothesis. The fingerprints in the light were real, but they were the fingerprints of the journey, not the traveler. They were the dust on the messenger's boots, not the messenger himself. This led directly to the second battleground, the coma. A coma is the fuzzy atmosphere of gas and dust that surrounds a comet's nucleus as it gets closer to the sunday. If Atlas was a comet made of ice, the sun's warmth should be causing that ice to sublimate, to turn directly from a solid into a gas, creating a visible halo. This halo is what makes comets look like fuzzy snowballs in the sky. And Atlas, for the most part, was not fuzzy. It remained a sharp, stellar point of light. The naturalists pushed back hard on this. They argued that a coma did exist, but that it was perhaps very faint, or that the outgassing was happening in sporadic, powerful jets rather than a uniform cloud. They pointed to data that showed a measurable rate of dust production coming from the object, a rate which, they noted, fell within the known range for some hyperactive comets. They suggested that perhaps its interstellar origin meant it was composed of more volatile ices, like nitrogen or carbon monoxide, which would create a different kind of coma, one harder to detect. The lack of a classic, obvious coma was a problem for their theory, but not, they insisted, a fatal blow. The artifactors saw it differently. To them, the sharp point of light was one of their strongest pieces of evidence. A machine wouldn't sublimate. It would remain solid. They offered their own explanation for the detected dust. If the object was shedding its cryogenic shield as it warmed up, that would release dust and ice, perfectly mimicking the activity of a comet. Others in the camp went further, suggesting the dust wasn't passive shedding at all. Was it perhaps a form of exhaust? Or even a defensive measure? A cloud of chaff released to obscure its true nature from prying eyes. The sharp point of light at the center of a faint, dusty cloud was, to them, not the sign of a comet, but the sign of a vessel moving through a cloud of its own making. And this brought the debate to its central, most contentious issue, the engine, the self-illumination, the light that shouldn't exist. This was the one piece of data for which the naturalist camp had the most difficulty providing a simple explanation. Their entire model was based on a cold object reflecting sunlight. The data from Hubble showed this was insufficient. The object was producing its own energy, its own light. This was the home turf of the artifactors. To them, the excess light and heat were not an anomaly. They were the most predictable feature of all. It was the unavoidable signature of power. They began to speculate on the nature of the engine that could be driving it. A fusion drive, like a miniature star, could power a vessel for eons, and its waste heat would cause the ship to glow in the infrared spectrum, a glow that would fit the observed data. Some suggested a matter-antimatter reaction, a technology of almost unimaginable power, where the glow was the result of annihilating particles, converting mass directly into energy. The more speculative papers even discussed quantum vacuum thrusters, theoretical engines that would draw energy from the fabric of space-time itself. The glow, they argued, was the hum of a machine, the warmth of a contained star, the unavoidable exhaust note of a technology far beyond our own. The light wasn't just light, it was information, it was proof of work. To counter this, the naturalists had to venture into the far realms of astrophysics. They needed to find a way for nature to create a glowing mountain. They proposed a few exotic, but not impossible, scenarios. The leading natural theory was that Atlas was not a comet, but the exposed core of a protoplanet from another solar system, one that was incredibly rich in radioactive isotopes like aluminum-26. This isotope, which was abundant in the early days of our own solar system, has a half-life of about 700,000 years and releases a tremendous amount of energy as it decays. If Atlas contained a massive concentration of it, the decay could heat the entire object from the inside out, causing it to glow for millennia. It would be a natural nuclear reactor, a radioactive mountain adrift in the void. Another theory suggested it might be a piece of a tidally destroyed hot Jupiter, a gas giant from another system that got too close to its star and was ripped apart. The surviving core could, theoretically, remain molten and glowing for millions of years as it cooled. These were compelling ideas, evidence of how creative the universe can be. But they all relied on Atlas being an object of extreme rarity, a 1 in a trillion cosmic lottery winner. The problem was, Atlas wasn't just a lottery winner in its composition, it was also a lottery winner in its orbit. The artifactors argued that invoking two separate, statistically miraculous explanations, one for the orbit and one for the glow, was a violation of Occam's razor. The simplest explanation, they contended, was the one that explained everything at once. It was designed. And so the debate stands. Every piece of evidence is a battlefield. The light's fingerprint says comet, but the journey could have put it there. The object is shedding dust like a comet, but it lacks a comet's fuzzy halo. The object glows with its own power, a feat that requires either a natural phenomenon of extreme rarity or a technology of profound sophistication. Both sides have built powerful, elegant arguments. Both are, in their own way, believable, and neither can prove the other wrong. The data we have is simply not good enough to land the knockout blow. It's like trying to determine the nature of a ship on the horizon by observing its distant light. Is it a fishing boat? A military vessel? A cruise liner? From a distance, they are all just points of light. To know for sure, you have to get closer. You need a better look. And a better look is coming. The stalemate was absolute. In the halls of universities and the forums of scientific institutions, the debate over 3I divided by Atlas had reached a fever pitch, a perfect and frustrating equilibrium. Every argument for a natural comet was met with a compelling counter-argument for an artificial probe. Every piece of data could be interpreted in two completely different ways. The scientific method, for a time, seemed to have failed. It had taken us as far as it could with the information at hand, and had left us standing at the edge of a cliff with two equally astonishing possibilities before us. The community realized that theory and debate were no longer enough. The time for arguing was over. The time for action had begun. The focus of the world shifted from "what is it?" to "what are we going to do about it?" This shift rippled outwards from the scientific community and washed over the entire planet. The story of Atlas escaped the confines of academic journals and became a global human event. It dominated the news cycle in a way no other story had in a generation. News channels ran 24-hour coverage, with countdown clocks in the corner of the screen ticking down to its closest approach. Newspapers resurrected their boldest headline fonts. Online, the object became a cultural phenomenon. Hashtags like The Visitor and Atlas Probe trended for weeks on end. Sophisticated animations of its impossible orbit went viral, shared by millions who were suddenly becoming amateur orbital mechanics. The world was captivated, not by a war or a political scandal, but by a single, silent point of light and the immense question it represented. Governments, typically slow to react to abstract scientific discoveries, were forced to respond. The statements that came from the White House, from the European Commission, from Beijing and Moscow were masterpieces of cautious diplomacy. They acknowledged the profound significance of the object and pledged their nation's full scientific resources to its study. They emphasized international cooperation. What they didn't do, at least not publicly, was use the word alien. But behind the scenes, a quiet, urgent conversation was taking place. For the first time, discussions at the United Nations Committee on the Peaceful Uses of Outer Space began to seriously address a formal contact protocol. It was a conversation that had been the realm of science fiction for 75 years, and now it was happening in the hushed, real-world corridors of international diplomacy. What do we do? Who speaks for Earth? Do we reply? The questions were dizzying. And for the rest of us, for the billions of people on the ground, the approach of Atlas triggered a profound and global introspection. Religions debated how the existence of another intelligence would affect their doctrines. Philosophers and artists found themselves with a sudden, electrifying new subject. New music, new art, new literature bloomed, all inspired by the silent visitor. For many, it was a source of incredible hope, a sign that we were part of a larger, more wonderful cosmic story. For others, it was a source of deep anxiety, a tangible manifestation of our own smallness in a vast and unknown universe. But for everyone, it was a mirror. It forced us to look at ourselves, at our divided planet, and to consider our identity not as nations or tribes, but as a single species, the inhabitants of a small blue world that was about to receive a guest. But hope and introspection would not be enough to solve the mystery. Solving it required technology, ingenuity, and one of the most ambitious mobilizations of scientific assets in history. The mantra became all eyes on Atlas. Observatories that were once busy studying distant galaxies retasked their instruments. The Very Large Array in New Mexico, a sprawling city of radio dishes, began to listen, straining to hear any whisper of an artificial signal from the object, searching for the telltale hum of technology amidst the cosmic static. Other telescopes, specializing in different wavelengths of light, from X-rays to microwaves, stared at the object, hoping to catch a flicker or a clue that other instruments might have missed. It was an unprecedented campaign of cooperation, a planet pointing all of its senses in one direction. At the heart of this campaign were two specific missions, two pieces of technology that represented our best, and perhaps only, chance to get a definitive answer before Atlas rounded the sun and began its long journey back out into the void. The first was the James Webb Space Telescope. Since its launch, Webb has been the jewel in the crown of astronomy, an instrument of breathtaking power. It resides 1 million miles from Earth, a golden honeycomb of mirrors shielded from the sun, allowing it to see the universe in infrared light. Infrared is the light of heat, and Webb is the most powerful heat-seeing eye humanity has ever built. This made it the perfect tool for interrogating Atlas. If the object was an artificial probe with a power source, it would be generating waste heat. It would have a thermal signature. Webb was powerful enough to not only detect that signature, but to analyze it. It could potentially tell the difference between the uniform, gentle heat of a radioactive rock and the localized, high-temperature output of an engine. Furthermore, Webb's spectrographs are exquisitely sensitive. If Atlas was venting any kind of gas, whether it was the natural outgassing of a comet or the artificial exhaust from a propulsion system, Webb could capture the light passing through that gas and give us a definitive chemical analysis, far more precise than any ground-based observatory could manage. Getting time on the Webb telescope is one of the most competitive processes in science. Astronomers plan their proposals for years. In the case of Atlas, all rules were bent. A consortium of space agencies allocated an emergency block of observation time. The pressure on the team at the Space Telescope Science Institute in Baltimore was immense. They were being given one shot, a few precious hours of observation time, to solve the greatest mystery of our time. Every second of the observation had to be planned with military precision. The second mission, and in many ways the more daring of the two, involved a trusted veteran of space exploration, the Mars Reconnaissance Orbiter, or MRO. MRO has been faithfully circling Mars since 2006. Its primary mission is to study the Martian surface, and it is equipped with the most powerful telescopic camera ever sent to another planet, an instrument called HiRISE. It is so powerful it can spot an object the size of a dinner table on the surface of Mars from an altitude of 300 kilometers, and Atlas, according to the blueprint of its trajectory, was going to fly right past MRO's front door. A wild, audacious plan was hatched at the Jet Propulsion Laboratory in California. The plan was to repurpose MRO. Instead of looking down at Mars, they would try to make it look sideways, out into space, and take a direct photograph of Atlas as it flew by. This was, to put it mildly, an incredible engineering challenge. The orbiter was never designed to do this. Its camera was built for tracking a slow-moving, predictable surface, not for snapping a picture of an object blazing past at tens of thousands of kilometers per hour. The software that controlled the spacecraft had to be completely rewritten. A team of engineers, some of whom had worked on the probe since its inception 2 decades ago, were brought back to write the new code. They had to account for the precise timing, the angle of the sun, and the enormous relative speeds. They had to figure out how to pivot the entire spacecraft and hold it steady enough for HiRISE to capture a clear image, and they had to do it all on a 20-year-old computer system, beaming the instructions across 150 million kilometers of empty space with a 20-minute light-speed delay. If anything went wrong, they wouldn't know until it was too late. It was a high-stakes celestial gamble. But the potential prize was the stuff of history, the first close-up photograph of an object from another star system, a photograph that could end the debate in a single, stunning frame. It could show us a cratered, tumbling rock, or it could show us the glint of metal and the unmistakable lines of a machine. And so, we find ourselves in the middle of this grand planetary effort. We have moved beyond the abstract and into the tangible. The story is no longer just about data points and theories. It is about human ingenuity, collaboration, and our collective, unyielding drive to know. The debate continues. But it is now a prelude to the main event. We are no longer just passive observers. We are active participants, using every tool at our disposal to prepare for our encounter. We are all now in a state of anticipation, waiting for the new flood of data that could confirm our wildest dreams or our most mundane explanations. This part of the story, the arrival of the definitive evidence, will unfold in real time over the coming weeks and months. It will not be a single news report, but a series of discoveries. And if you want to be there for each new chapter of this story, as it is written, the surest way is to make sure you're subscribed to this channel with your notifications turned on. That way, you won't miss the moment the next crucial piece of the puzzle falls into place. Because for a story of this magnitude, you'll want to be there right when it happens. The year turned. Humanity crossed the threshold into 2026, carrying with it a sense of profound and shared anticipation. The theoretical debates and philosophical discussions that had dominated the previous months began to fade into the background, replaced by the stark, tangible reality of the approaching encounters. The time for guessing was over. The time for seeing was at hand. 2 missions, 2 of humanity's most sophisticated remote eyes, were now poised to intercept the visitor, ready to transform it from a theoretical puzzle into a physical reality. The first test, The first true moment of revelation would happen in the cold, thin atmosphere of Mars. At the Jet Propulsion Laboratory in Pasadena, California, the atmosphere in the mission control room for the Mars Reconnaissance Orbiter was a unique blend of extreme tension and practiced calm. For weeks, they had been preparing. The final lines of code for the pivot maneuver had been written, tested in simulations 1,000 times, and then, days ago, bundled into a signal and beamed across the solar system. The commands had travelled for nearly 20 minutes at the speed of light to reach the aging orbiter. The instructions were now on board. The die was cast. There was nothing left for the team on the ground to do but watch the telemetry, drink coffee, and trust in the mathematics and the resilience of a machine launched almost 2 decades ago. Their target, Atlas, was closing the distance with incredible speed. Their instrument, the MRO, was a marvel of engineering, but it was also a creature of habit. For 20 years, its gaze had been fixed downwards, mapping the canyons, craters, and polar ice caps of Mars in exquisite detail. Now, they had asked it to do something it had never done before. They had asked it to look up. The plan was a masterpiece of celestial timing. For just 82 seconds, as Atlas streaked past the orbit of Mars, MRO would execute its custom software. It would pivot its entire body, aiming the high-resolution, high-rise camera not at the red dust below, but at the black emptiness of space, hunting for a single, fast-moving point of light. On the main screen in the control room, a clock counted down, not to an explosion or a landing, but to a fleeting, silent passage. When the clock hit 0, the room was utterly still. No one spoke. They were watching the data streams from the orbiter, looking for any sign of trouble, any unexpected wobble, any spike in temperature, any indication that the complex maneuver had put the spacecraft into safe mode would mean failure. The seconds ticked by, stretching into an eternity. 82 seconds, the duration of the imaging sequence. Then came the agonizing wait for the signal confirming the maneuver was complete. Another 20-minute journey across the void. The team watched their screens, their faces illuminated by the green glow of nominal data streams. The orbiter was stable. The command sequence had, it seemed, completed without a hitch. But the real proof was still hours away. The data captured by the high-rise camera was too large to be sent back in real time. It was stored on board, and now the orbiter was slowly beaming it back to Earth, one packet of data at a time, through the deep space network. It was a process like downloading a giant file on the slowest internet connection imaginable. For hours, all they had was a progress bar, a slowly creeping line on a screen that represented the most anticipated photograph in human history. When the final packet arrived, the raw data was not a picture, but a long, chaotic strip of black, white, and grey pixels. Image processing specialists took over, their fingers flying across keyboards as they stitched the data together, corrected for distortions, and adjusted for the insane relative velocities. In the control room, the lead scientists gathered around a large monitor, waiting for the processed image to load. The screen flickered, and then it was there. A collective, audible gasp went through the room. It was followed by a silence even more profound than before. The photograph was not blurry. It was sharp, and it immediately, definitively, ended one part of the debate. The object was not a comet. It was not a tumbling, potato-shaped, irregular asteroid. The image, though taken from a great distance, clearly showed an object of perfect and startling symmetry. It was extraordinarily elongated, a feature that had been theorized but never proven. Its shape was a long, needle-thin spindle, at least 5 times longer than it was wide. There were no visible wings, or engines, or windows. The resolution was not nearly high enough for that, but its form was undeniably artificial. It was a shape forged not by the random collisions of a protoplanetary disk, but by purpose. It had a distinct front and back. It had clean, unbroken lines. It looked less like a rock and more like a javelin, hurled across an interstellar ocean. The image flashed across the world. It was the definitive proof that Atlas was not a natural object in any conventional sense. But the photograph, as revolutionary as it was, created as many questions as it answered. The shape was artificial, but what was it? A vessel, a weapon, a piece of cosmic debris from a long-dead civilization? The image was a silhouette, a shadow. To understand its true nature, they needed more than just its shape. They needed to understand its temperature, its energy output, its composition. The world's hope now rested on the golden eye of the James Webb Space Telescope. Weeks later, at the Space Telescope Science Institute, the tension was of a different sort. The JPL team had been fighting with mechanics and software. The Webb team was fighting with the fundamental limits of light and chemistry. The MRO image had raised the stakes to an almost unbearable level. They were no longer looking at a strange anomaly. They were looking at a manufactured object from another star. Their observation was humanity's chance to perform a remote chemical analysis, a forensic investigation from 1,000,000 miles away. The command sequence was uploaded. The great telescope, a marvel of human ingenuity, gracefully turned its array of 18 golden hexagonal mirrors towards its target. The instruments that would perform the key analysis, the near-infrared spectrograph, or near-spec, and the mid-infrared instrument, MIRI, began their long exposures. MIRI's job was to create a heat map. It would stare at the object, collecting the faint infrared photons to build a picture of its thermal energy. Was it uniformly cold, as a dead piece of technology would be? Or was it radiating heat? And if so, from where? NIRSpec's job was to taste the light. It would analyze the faint halo of dust that MRO had confirmed surrounded the object, looking for the chemical fingerprints of vented gas. If it was a machine, was it venting propellant? Were there noble gases like xenon used in our own ion drives? Or were there the simple molecules of a comet, proving that the cryogenic shield theory was correct? For several hours, Webb stared, its instruments drinking in the faint light of the visitor, collecting the raw data that held the key. The data came back, and once again it was delivered to a team of anxious scientists in a quiet room. The first results to be processed were from MIRI, the heat map. An image of the spindle shape appeared on the screen, but this one was colored not by visible light, but by temperature. The result was immediate and shocking. The object was not uniformly cold, nor was it uniformly warm. The heat signature was concentrated in specific, distinct locations. There were 3 brilliant points of thermal energy, glowing like embers, arranged in a precise triangular pattern near what was presumed to be the rear of the object, and there was a fainter, but still distinct, warmth emanating from a thin line running along its central axis. It was not the heat signature of a rock warmed by the Sunday. It was the heat signature of a machine with a working power system. The hotspots were exactly where you might expect to find engines or power plants. The room was electric. They had found the engine, but the final piece of the puzzle, the most important piece, would come from NIRSpec, the spectrum. What was the object venting? A scientist brought the final processed spectrum up on the main screen. The graph showed a horizontal line representing the light intensity across all the different colors. If there were gases like water or carbon dioxide, there would be deep valleys, absorption lines, in that graph. The team leaned in, searching for the familiar fingerprints of a comet. They found nothing. The line was almost perfectly flat. There was no water, no methane, no carbon dioxide, none of the chemical signatures of a comet. The faint cloud around Atlas was not the result of sublimating ice. The cryogenic shield theory, at least in its simplest form, was wrong. But that wasn't the strangest part. While there were no absorption valleys, there were a series of incredibly faint, but statistically significant, emission spikes. They weren't valleys, they were needles. Sharp, thin spikes of light in a complex, repeating pattern, clustered in the deep infrared portion of the spectrum. A specialist ran the pattern through a database of every known atomic and molecular signature. The search returned 0 results. The pattern did not match any known natural element. It did not match any molecule known to science. It was a chemical fingerprint for a substance that, as far as humanity was concerned, did not exist. It was ordered. It was complex. And it was completely alien. The object was not venting random gases. It was emitting a precise, structured, and deeply unnatural signal. It was not a random scream of heat and light. It was a message. The scientists stared at the screen, at the series of sharp, needle-like lines. The perfect geometry of the MRO image had been shocking. The hotspots of the MIRI image had been astounding. But this was something else entirely. This was a language. The object was not talking, but for the first time, in a vocabulary of light and chemistry that we could not possibly comprehend, it was beginning to write. The data from the James Webb Space Telescope did not arrive with a thunderclap, but with a profound and unnerving silence. In the control rooms and laboratories, the frantic energy of the preceding weeks evaporated, replaced by a quiet, collective awe that bordered on dread. The debate was over. There was no longer a naturalist camp and an artifactor camp. There was only the staggering, indigestible truth. The photograph from the Mars Reconnaissance Orbiter had shown the world a machine. The data from Webb had shown the world a ghost in that machine, a power source, and a chemical signature that belonged to no known science. The word alien was no longer a speculative whisper. It was the only word left. Humanity had its proof. And that proof was more complex, more beautiful, and more terrifying than anyone had ever dared to imagine. The immediate focus of the entire scientific world narrowed to a single graph, the emission spectrum. From NIRSpec, those sharp, repeating spikes of light, the fingerprints of an impossible chemistry. For months after their discovery, the world's greatest minds in cryptography, quantum physics, linguistics, and chemistry threw themselves at the problem. It was a message. It had to be. But it was a message of a type we were completely unprepared for. It contained no simple binary, no repeating prime numbers, none of the universal greetings that humanity had so hopefully beamed into space for decades. One school of thought argued that the pattern was a form of data compression, a message of such density that every spike of light represented entire libraries of information. They theorized that it could be a technical blueprint for the object's engine, or a biological map of its creators, or the history of a civilization, all encoded in a language of light. Teams used supercomputers to run endless simulations, trying to find a key, a mathematical Rosetta Stone that would unlock the meaning. They found nothing but deeper and more intricate layers of mathematical complexity. The pattern was undeniably ordered, but it was a form of order whose logic remained stubbornly out of reach. Another, more unsettling theory began to gain traction. It proposed that we were making a fundamentally human mistake. We were assuming that the emission was a deliberate message for us. This theory suggested that the pattern was not a message at all, but a byproduct. It was, in the simplest terms, the object's exhaust. It was the waste product of a physical process so advanced that its garbage was more complex than our highest forms of mathematics. It was like a primitive tribe finding a discarded smartphone and worshipping its screen as a divine artifact, never realizing it was just the cast-off tool of a passing traveler. This idea was, in many ways, more terrifying than that of a hostile message. It implied an intelligence so far beyond our own that we were not even a consideration. We were simply the ants, watching the trail of a jetliner, seeing the shape, hearing the sound, but having no possible conception of the principles of combustion or aeronautics that made it fly. This revelation that we were in the presence of not just another intelligence, but a vastly superior one, sent a seismic shock through the foundations of human culture. The question, "Are we alone?" had been the great, unanswered mystery that had haunted us since we first looked up at the stars. On a specific Tuesday in the spring of 2026, that question was answered with a definitive no. And in the silence that followed, a new, much heavier question took its place. What is our place in this universe now? Science itself was the first to be transformed. The flat spectrum from Atlas was a declaration that our understanding of chemistry was incomplete. The patterned emission lines hinted at stable elements beyond our periodic table, or forms of matter held together by forces we had not yet discovered. The heat signature of the object's power source became a holy grail for physicists, a clear indication of a method for generating vast amounts of energy that did not conform to our models of fusion or fission. It was as if a medieval alchemist had been shown a working nuclear reactor. They could see the result, the incredible power, but the principles behind it were pure magic. Overnight, entire fields of theoretical physics were born, all dedicated to working backwards from the Atlas data, trying to build a new science that could explain the existence of this impossible machine. Philosophy and religion underwent a similar, more painful revolution. For millennia, our belief systems had been built around the central importance of humanity. We were the pinnacle of creation, the sole inheritors of a divine spark. Atlas, in its silent passage, shattered that mirror. The world's religions scrambled to adapt. Some embraced the visitor as a manifestation of the divine, a new prophet in metallic form. Others condemned it as a malevolent trick, a grand deception. Many simply fell silent, unable to reconcile their ancient texts with the stark, spindle-shaped reality now orbiting our Sunday. A new era of philosophy began, one defined by a concept that came to be known as cosmic humility. We were not the center of the story. We were, perhaps, not even in the main chapter. We were a footnote in a book whose language we could not read. And in the halls of power, the initial, fragile unity of the global response began to crack. As long as Atlas was a mystery, it was a unifying force. But as soon as it became a confirmed artifact, it became a prize. It became a source of potential power, knowledge, and technology that could change the balance of power on Earth forever. Geopolitical tensions, long simmering, came back to a boil. Who owned the data from Webb and MRO? The nations that had funded and built them claimed primary rights. Other nations argued it was the shared heritage of all humanity. The debate at the United Nations grew heated. Should we attempt to send a signal in return? The United States and China advocated for a cautious, listen-only approach. Russia and a bloc of other nations argued for an active response, a message that announced our presence and our intelligence. A private consortium of billionaires announced their own plan to launch an uncrewed probe to try and intercept Atlas, an act of cosmic piracy that sent shockwaves through the international community. The discovery that should have united us in awe was now threatening to divide us by ambition. Beneath all of this, the final, deepest question remained. Why was it here? With no translatable message, all we had was speculation. Was it a scout, the first of many, passively gathering data before a larger arrival? Was it a seed ship, an automated biological laboratory carrying the building blocks of life to be deposited on promising worlds, making us, perhaps, the descendants of an earlier, similar visitor? A more poignant and strangely popular theory suggested it was a derelict, a ghost ship from a civilization that may have died out millions of years ago, its automated systems still faithfully carrying out their final mission, its engines still glowing with the last vestiges of a long-extinguished power. We were not seeing a visitor, but a monument, a tombstone of a civilization far greater than our own. Or perhaps it was the most romantic idea of all, that it was a message in a bottle, thrown into the cosmic ocean not for a specific recipient, but for anyone who might find it, that its systems were designed to activate upon entering a solar system, to briefly and subtly announce its presence, not with a loud radio shout, but with a gentle, impossibly complex glow, a calling card for those with eyes sharp enough to see, a quiet affirmation that we were here. We will likely never know the answer. As we speak, 3I divided by Atlas has passed its perihelion. It is now moving away from the Sun, its long journey carrying it back out towards the orbit of Jupiter and beyond. Every day, its faint, impossible light grows a little dimmer. It is leaving. It did not stop. It did not speak in a language we could understand. It simply passed by, a silent witness to our existence. And in doing so, it held up a mirror and showed us our true reflection. The visitor is leaving. We are, in a very real sense, forever changed. There is now a clear dividing line in the history of our species. The time before we knew we were not alone, and the endless, uncertain and exhilarating time that comes after. We have been fundamentally and irrevocably altered, not by a conversation or an exchange, but by a simple, undeniable presence. We have overheard a single line from a conversation in a language we do not speak, and it has told us that the universe is infinitely larger, stranger, and more magnificent than we ever dreamed. The great silence has been broken. The question is no longer if we are alone. The question is, and will be for the rest of our time, what will we do with the knowledge that we are not? It has been 10 years, a full decade since the passage of 3I divided by Atlas. The visitor has long since departed, a ghost now receding into the interstellar darkness, its faint, impossible light utterly lost to even our most powerful telescopes. For a new generation of children born in its wake, the story is a modern myth, a foundational piece of history, as significant and as distant as the moon landing. But for those who lived through it, for the scientists who saw the data and the world that held its breath, the silence that followed has been as profound and transformative as the encounter itself. The event is over. The echo, however, remains. This is the story of that echo, and of the world it reshaped. This is the story of the inheritance of Atlas. The first and most immediate change was one of consciousness. The generation that came of age after 2026, colloquially known as the Atlas generation, grew up in a fundamentally different reality. They were the first humans in history for whom the answer to the question, "Are we alone?" was a settled fact. This knowledge was woven into the fabric of their education, their art, their aspirations. Astronomy became a core subject in elementary schools. The image of Atlas's spindle-shaped form, captured by the Mars Reconnaissance Orbiter, became an icon as recognizable as the planet Earth itself. The strange, repeating emission lines from the Webb telescope were set to music, incorporated into digital art, and became a symbol of the profound and the unknown. These children grew up with a different perspective on humanity's place in the universe. The old divisions and conflicts of Earth, while still present, seemed smaller, somehow less significant, when viewed against the backdrop of a cosmos known to be inhabited by others. A sense of cosmic humility, once a niche philosophical concept, became a mainstream cultural attitude. This had tangible effects. International cooperation on space projects, once a fraught political process, accelerated dramatically. The budgets for space exploration and fundamental physics research swelled, driven by a global consensus that understanding our place in the universe was no longer a luxury, but a necessity. We had been shown the door to a much larger room, and a planetary obsession took hold with finding other doors, and perhaps, one day, the key. While culture adapted, science embarked on the most difficult project it had ever conceived, the decipherment project. The patterned emission lines from the Webb data became humanity's ultimate puzzle. The initial hope for a quick translation, a cosmic Rosetta Stone, quickly faded. The signal was not a language in any human sense. It lacked the redundancy and structure of communication. After years of intense analysis by a global consortium of supercomputers and AI, a consensus began to emerge. The signal was not language. It was mathematics, and it was a form of mathematics, describing a physics that was utterly alien to us. The pattern, analysts believe, is a byproduct of the object's power source. It is, in effect, a map of the physical laws inside its engine, and those laws are different. The spikes of light are thought to represent energy state transitions of exotic matter or vibrations from a higher dimensional space, or the signature of a controlled reaction that draws power from the quantum vacuum. The data was a blueprint for a new physics, but it was written in a language of outcomes, with none of the underlying grammar. We had been given the answer to the final exam, with no way of showing our work. This realization sparked a revolution in theoretical physics. The old standard model, which had so successfully described our universe, was now seen as what it was: a local ordinance, a set of bylaws that worked perfectly in our own quiet neighborhood, but was not the universal law of the land. Physicists were now engaged in a slow, painstaking process of archaeophysics, trying to reverse engineer the laws of the visitor's universe from the faint, ghostly light it had left behind. This quest for a new physics was not merely an academic pursuit. It was the foundation for the second great global effort of the post-Atlas era, the technology race. The heat signature of Atlas's engine was proof of a viable, hyper-efficient power source. The nation or entity that could replicate it would change the world forever. A new kind of Cold War began, one fought not with spies and missiles, but with particle accelerators and quantum computers in secretive, heavily guarded research facilities. The United States initiated the Prometheus project, Europe founded the Carina Institute, and China launched the Heavenly Ladder program. Trillions of dollars vanished into these black budgets, all chasing the ghost in Atlas's machine. The public was shown tantalizing, occasional glimpses of the progress. Breakthroughs in materials science, new theories of energy manipulation, and strange new particle discoveries. But the core research remained top secret. The dream was clean, limitless energy. The fear was a new, ultimate weapon. The race was fueled by the knowledge that this was not science fiction. The proof of concept had already flown through our solar system, a silent testament to the fact that it was possible. Humanity had been given a glimpse of the fire of the gods, and now we were desperately trying to learn how to steal it for ourselves, hoping we wouldn't get burned in the process. While science and government chased the hardware, the rest of humanity grappled with the software, the profound social and spiritual impact of the encounter. New religions were born overnight. The children of the spindle saw Atlas as a divine messenger, its emission lines a sacred text. They built cathedral-like observatories and held vigils, praying for its return. On the other end of the spectrum, doomsday cults emerged, preaching that Atlas was a harbinger of an invasion, a scout for a hostile force. They advocated for a planetary defense system, a ring of weapons to guard against the darkness. For most people, the effect was more subtle, a quiet re-evaluation of their place in the world. The discovery became a new litmus test for faith, forcing believers of every creed to ask how their worldview could incorporate a universe that was not only teeming with life, but with intelligence far surpassing our own. It created a strange, low-level, global anxiety. We were now living with the knowledge that there were giants in the forest. We had only seen one, and it had ignored us. But we now knew the forest was not ours alone. This led to a new, more profound iteration of the Fermi paradox, which came to be known as the Great Silence. The original paradox asked, if the universe is full of life, where is everybody? The new paradox was far more chilling. We know they are out there, so why is it so quiet? The passage of Atlas had proven that interstellar travel was possible, that advanced civilizations existed. So why had we only seen one? Was the universe a far more dangerous place than we imagined, forcing civilizations to hide in silence? Was the gulf between intelligences so vast that communication was simply impossible, like an ant trying to talk to a human? Or was the most terrifying answer the truth, that they knew we were here, and for reasons we could not comprehend, they had chosen not to speak? The silence of the universe, once a comforting emptiness, had become a deafening, conscious act, and so we live in the echo. 10 years later, the world is undeniably, irrevocably changed. The Vera C. Rubin Observatory in Chile, which came online a few years after the passage, now catalogues the sky with unprecedented detail. It discovers new interstellar objects every few months, and every time one is found, the world holds its breath. But they have all been mundane, chunks of rock, ice, and dust, natural, chaotic, and silent. They only serve to highlight the profound, shocking uniqueness of our one and only confirmed visitor. Atlas gave us no answers, no welcome, no warning. It simply revealed the scale of the universe and our own infinitesimal place within it. It bequeathed to us a single, transformative piece of knowledge, and then vanished back into the night. It left us with its echo, a legacy of wonder and fear, of unity and division, of humility and ambition. It left us, finally and forever, alone with the knowledge that we are not. For 10 years, the world has lived with the legacy of 3I divided by Atlas. The public story, the one we have told ourselves, has been one of wonder, of philosophical awakenings and a great unified scientific quest. It is a comforting story, one of a species rising to the occasion, looking up at the stars with newfound wisdom. It is also a fiction. It is the sanitized, official history. In the decade since the visitor's passage, while the world was distracted by the grand questions of our place in the cosmos, a second, secret story was unfolding here on Earth. It was a story not of wonder, but of fear, not of unity, but of division, not of discovery, but of a desperate, terrifying race for power. This is the story of the Atlas Gambit, the secret war for the visitor's inheritance. The war began the moment the first definitive data packet from the James Webb Space Telescope reached Earth. While the public saw a series of inscrutable, patterned lines and a heat map of a strange machine, the world's intelligence agencies saw something else entirely. The greatest strategic prize in human history. The raw, uncalibrated data from Webb was a potential key to a new physics, to limitless energy, and to weapons that could make a nuclear bomb look like a firecracker. And so, before the scientific community had even had a chance to hold its first press conference, a silent, frantic war was being waged in the shadows of cyberspace. Elite hacking units from the United States, China, Russia, and the European Union launched simultaneous, sophisticated cyber attacks against each other. The targets were the servers at the Space Telescope Science Institute, the Deep Space Network relay stations, and the private networks of the lead scientists themselves. It was a digital heist of unprecedented scale. Everyone wanted the raw, unfiltered data for themselves, and they wanted to know what their rivals had. They deployed zero-day exploits and quantum-resistant encryption breakers, fighting for a prize they didn't yet understand. The public narrative was of global scientific cooperation. The digital reality was a frantic, multi-front battle for a technological kingdom they all coveted. In the first 72 hours, the data was stolen, copied, and secured in digital vaults around the world. And the secret arms race had begun before the public even knew there was a race to be run. While the world was shown pictures of new, gleaming, international research centers being built, the real work was happening elsewhere. In the quiet deserts of Nevada, a new, unnamed facility was excavated beneath the ground, a place designated only as Station Kestrel. In the vast emptiness of the Siberian tundra, Russia reactivated a deep earth research bunker, Platform Zarya. China established a similar facility on a remote plateau in the west, named simply the Institute. These were the black sites of the Atlas Age. They did not officially exist. They were staffed by scientists who, to the outside world, had simply disappeared. In the years between 2026 and 2029, over 200 of the world's leading physicists, AI theorists, materials scientists, and xenolinguists quietly vanished from public life. Their university profiles were scrubbed. Their social media went dark. Their colleagues were told they had accepted lucrative private sector contracts with non-disclosure agreements. The truth was far more chilling. They had been nationalized. Their knowledge was deemed a state secret, too valuable and too dangerous to be left in the civilian world. Some went willingly, patriots eager to serve their country. Others were coerced, their families threatened, their lives erased. They were taken to places like Station Kestrel and Platform Zarya, given limitless resources, and tasked with a single, terrible objective: to weaponize the physics of the visitor. The sanitized public story was that the world was chasing clean energy. The secret reality was that the first and primary goal was military supremacy. The research was divided into two main thrusts. The first was power and propulsion. The heat signature of Atlas's engine suggested a power source that could run for millennia. To replicate it would mean not just powering cities, but creating fleets of aircraft that never needed to refuel, submarines that could stay submerged for a lifetime, and space-based weapons platforms of unimaginable endurance. The second, and far more terrifying, thrust was what came to be known internally as exotic effects. The strange emission lines from Atlas, the ones that hinted at a new physics, were not just a curiosity. They were the key. If the physics of the visitor was different, could that difference be weaponized against an enemy who was still bound by the old laws? The theories that emerged from these black sites were the stuff of nightmares. Scientists at Station Kestrel worked on dimensional resonance munitions, theoretical warheads that would not explode, but would instead vibrate at a frequency that could destabilize the very fabric of matter, causing structures to simply dissolve into dust. At Platform Zarya, Russian scientists pursued vacuum energy cascades, attempting to harness the zero-point energy of the void to create a directed energy weapon that could boil oceans or ignite atmospheres. This was not theoretical work conducted on whiteboards. They were building devices, and they were failing. In 2031, at the Chinese facility known as the Institute, an experiment with a prototype vacuum energy extractor went critical. There was no explosion. Instead, for a period of 4.3 seconds, a perfect sphere of absolute nothingness, 200 meters in diameter, appeared around the test chamber. Everything inside the device, the researchers, the building, the very air itself, ceased to exist. The event was so anomalous it was detected by seismic sensors around the world, explained away publicly as a minor earthquake. But within the intelligence community, it was a clear signal. The race was not only real, but it was also lethally dangerous. We were playing with a fire we did not understand, and we had already begun to burn ourselves. The immense psychological pressure on the scientists within these programs was unimaginable. They were isolated from their families and the world, living in a gilded cage where they held the keys to a new reality, but were being forced by their governments to forge them into swords. It was from this crucible of conscience that a whistleblower finally emerged, a brilliant physicist who had been part of the original web data analysis team. She had been taken to Station Kestrel in its early days. For nearly 8 years, she worked on the resonance weapon program, growing increasingly horrified by the purpose of her work. She began to secretly copy terabytes of project files, experimental data, and internal memos. In 2034, she escaped. Her story, and the cache of documents she brought with her, forms the basis of what we know now. It was she who revealed the existence of the black sites, the truth behind the disappearing scientists, and the horrifying reality of the new arms race. Her documents showed that far from uniting us, the legacy of Atlas had been to pour gasoline on the dying embers of our old national rivalries. The visitor hadn't given us wisdom, it had given us a bigger stick. And so, we are left with a new, and far more disturbing, reality. The philosophical awakening of the Atlas generation is real, but it is built upon a carefully constructed lie. The public looks to the stars with hope, inspired by the grand, cooperative scientific quest. But the true inheritance of Atlas is not being debated in universities. It is being weaponized in bunkers deep beneath the earth. The greatest irony of all is that for 75 years, humanity scanned the skies, terrified of a potential threat from beyond. We feared an invasion, a hostile fleet, a cosmic destroyer. But the visitor was silent. It was passive. It did us no harm. It simply showed us what was possible. And we, in our infinite ambition and our endless fear of each other, immediately set about turning that possibility into a new and better way to destroy ourselves. The true threat was never the alien visitor. It was the reflection of our own darkest impulses we saw in the starlight it left behind. The true threat was never the alien visitor. It was the reflection of our own darkest impulses we saw in the starlight it left behind. This secret war, fought in the shadow of the greatest discovery in history, is a story that is still unfolding, with new truths clawing their way out of the darkness every day. The documents and testimonies we've explored here are likely just the first chapter. If you believe these hidden stories must be brought into the light, and you want to continue this journey of discovery as more information is uncovered, the simplest way to ensure you don't miss a single revelation is to subscribe and enable notifications. And your own thoughts are a crucial part of this conversation. What do you believe the correct path forward is for a species that has been given the keys to the universe, but still seems determined to find new locks for its own cages? Let's discuss it in the comments below.